This is my Project 2 presentation on surface treatments. In this presentation, I'll be going over the different uses for surface treatments, as well as the different types, including shot peening, roller burnishing, explosive hardening, cladding, electroforming, anodizing, case hardening, and surface texturing. I'll also be talking about smart coatings and how that new technology is improving different surface treatments. Surface treatment methods are used in a wide variety of materials for several reasons. These reasons include improving surface appearance and roughness, improving a surface's resistance to indentation, erosion, and wear, improved resistance to oxidation and corrosion, improved resistance to fatigue, and improved surface colors and textures. Shot peening is used mainly on jet engine parts, springs, gears, and shafts. Small balls called shots are typically made out of ceramic, glass, or cast steel. The size of these shots are typically between 0.005 to 0.2 inches in diameter. These shots are fired onto a surface to create non-uniform plastic deformation on a surface. Typically, they create indents that are a maximum of 0.05 inches into the material. This deformation causes the material to have compressive stresses on the surface, which helps with the lifespan of the material. Laser shot peening, water jet peening are also similar methods, but use laser shocks and water to produce a similar effect. Roller burnishing is typically used on conical, cylindrical, or flat surfaces. This surface treatment method involves using a hard and polished roller at cold temperatures. This method is typically used to improve a surface's finish by removing tool marks and scratches. A similar method called belizing is used to treat the inside of a cylindrical object. This method uses a smooth ball that is guided through the cylinder to achieve similar surface treatment effects. Explosive hardening is typically used to treat metal objects that require a large hardness, such as railroad tracks. This method involves using explosives directly on the surface of the desired material. These explosions can introduce pressures as high as 5 million psi onto the surface of the material that's being treated. This method is mainly used to increase the hardness of a material without changing the material's original shape. Cladding is used mainly with aluminum and steel clads. This method uses corrosion-resistant pure metals such as aluminum or steel. This thin layer of pure metal is applied to a surface through the use of rolls. This method is used mainly to protect surfaces from potential corrosion. Other types of cladding, such as laser cladding and cladding that uses dyes, are also used in manufacturing. Electroforming is typically used to create small parts. The process involves putting a metal coat over a mandrel. These mandrels are typically made out of plastic, wax, or certain alloys. Once the mandrel and metal coat have been shaped properly, the mandrel is either dissolved or melted to leave the metal coat as the finished product. This method of surface treatment is typically only used for small, detailed parts. Anodizing is another method of surface treatment that is typically used to add color to a material as well as provide corrosion resistance. The typical products this method is used to create are keys, picture frames, and aluminum utensils. The process involves placing the workpiece into an acid bath while passing electricity through it. This allows for an oxide layer to form on the outside of the workpiece. Additionally, to add color to the workpiece, different dyes can be used. Case hardening is a process that is typically used for products such as fasteners, bearings, shafts, and cams. The process involves placing the workpiece into an atmosphere that contains an element that changes the properties of the workpiece when heated. These elements are typically boron, carbon, or nitrogen. Lasers can also be used in this process to provide more heat to the workpiece. After the material is heated and cooled, the surface should have a larger hardness than it previously did. Surface texturing methods are also used to change a material's surface because of either aesthetic or functional reasons. The process can be accomplished through the use of atomic oxygen, laser pulses, electric arcs, or etching. These methods produce conical shapes on the surface of a material. Smart coatings are a new technology being used in the field of surface treatment. These coatings are unique in that their effects change based on external environmental factors. These factors include pressure, temperature, light, and heat. Nanomaterials are also being implemented into smart coatings to provide even more benefits. These nanomaterials can affect the properties of a material, such as corrosion resistance and increased hardness. These smart coatings are also being used in different industries such as automotive, aviation, healthcare, and construction. In the automotive industry, smart coatings can be used to reduce scratches as well as prevent dirt buildup, as well as change the color of a car's outside surface. The aviation industry can use smart coatings to reduce friction. The healthcare industry can use smart coatings to reduce the number of germs on surfaces. The construction industry can use smart coatings to make buildings more energy efficient. Some potential improvements to smart coatings are having more visual effects as well as being more environmentally friendly than they currently are. After researching these different methods of surface treatments, I've come to the conclusion that different surface treatment methods provide different benefits. Certain methods can only be used on certain shapes. Smart coatings are majorly changing how surfaces are coated, and surface treatment methods are still being improved. These are the sources I used for this presentation.